Okay, so for 3D, okay, obviously we want to have a 12-meter south line, okay, like so. And then our next line is 15 meters long, but it's 55 degrees east of south, or east of north, sorry, east of north. Okay, so I'm going to go 55 degrees, that's quite a ways, okay, and then I'm going to draw a line. Actually, that's not 55 degrees, I'll do a better job of that. Okay, so even further down, okay, and then I'm going to draw my 15-meter line. All right, so definitely longer than my 12-meter line. Right, there's its triangle. So that's 55 degrees. This is 15 meters. Okay, this would be the x component. This would be the y component. And then my resultant goes from my initial position to my final position, like so. And there's more than one way to draw this triangle. Okay, I could draw the triangle this way. That's the way I would be inclined to draw it, because then it's not overlapping any of my other triangles. But it would be equally correct to draw it this way. Okay, either one of those will get me the same answer. The only thing they'll do is one will get me an angle that is relative to due east, and the other one will give me an angle that's relative to due south. The answer here is actually this one, the 75 degrees east of south. Right? But that doesn't mean that 15 degrees south of east is also not a valid answer. It is. Okay? It just depends on which way you draw the diagram. Does that make sense to everybody? Okay? Either way here, okay, 75 degrees east of south and 15 degrees south of east point the same way. All right? So either one of them is equally valid for telling someone how to get from here to here. Okay? So we've got our x and our y here. Okay, I'm going to not use the second triangle I drew because I don't like when it overlaps. Okay, so I'm just going to get rid of it. Okay, so now that I have those, now I need to find my x's and y's. And if I look carefully at my diagram, okay, I can see that red x and blue x are the same length. All right, so I can save myself a little bit of time there. Yes. Okay. So what I need to do is find these sides here. So I'm going to find red x, right, by taking the 55-degree angle. X is the opposite side, so that'll be sine of 55 degrees times the hypotenuse, 15. That will give me red x. Okay, so sine of 55 times 15. That gives me 12.287. Again, you want to keep all those decimals, and I will too. Okay, 12.287 meters east. Then I'm going to find y. Okay, y is the adjacent side, so that'll be cos of 55 degrees times 15. All right, and we're looking at 8.604 meters, and that one is north. Right? For my black vector that came first, okay, it only has a y component, 12 meters south. It doesn't go east or west, so I have nothing to report there for the x component. Everybody all right with that? Okay, that's also why we observed a minute ago that red x and blue x are the same or equal, okay? Because that's the only, red x is the only time in this trip where the object goes east. All right, so now that we have those, now we can find our resultants x and y. All right, so blue x is equal to red x, okay, which is 12.287 meters. All right, so that saves me a fair amount of time, and that's east. All right, to find blue y here, okay, I'm going to take the 12 meters south, and then I'm going to subtract the amount north that I went when I was coming back along the red vector. So that will mean I will take my 12 meters south, and I will subtract the answer I got for y, the 8.60. All right, so my overall blue y component is 3.396 meters, or kilometers, I guess. Is it meters or kilometers? Meters. It's meters, okay. Meters, and that is south. All right, so now I've found both of those, right? still the same set of steps that we've used in every other vector component addition question we've done. I drew the diagram. I found all the x's and y's. I used them to find my resultants x and y. Now I'm up to, I need to find the magnitude of my resultant, which in this case represents displacement. Okay, so d will equal the square root of 3.396, obviously with all the decimals, squared, plus 12.287, again with all the decimals, okay, squared. Okay, plus 12.28728066 squared. All right, so my overall magnitude for my displacement is 12.748 meters. All right, and now I also need to find the direction, because obviously this is a vector addition question. I can't finish here without a vector. All right, I have to have a direction on that. So theta for me will be tan to the minus 1 of the opposite side. For me, the way I drew this triangle, the opposite side is the y. So 3.396 divided by 12.287. That will get me my angle. All right, so second tan of 3.396353455 divided by 12.28728.066. All right, so I'm getting 15.45 degrees. And for me, that is south of east. All right, so if I look back to my question here, I'm looking at my significant figures. It's 2. Okay, so my final answer here will look like this: 13 meters at 15 degrees south of east, or as the key says there, 75 degrees east of south. Either one would be acceptable. Now, to give you an idea of a Marx breakdown on a question like this, okay, I would give you 1 mark for the diagram. Then I would give you 1 mark for each one of the vector components you had to solve for, right, for x and y. Okay? I would give you a mark for each one of getting the final x and final y, unless, like in this question, there was no math in getting the final x. Okay? It was the same as another number, so you'd have a mark here for the y. Okay? You'd have a mark for Pythagorean theorem, a mark for your trig here, and a mark for your final answer. Okay? So you're looking at like a 6 or 7 mark question here. Okay? So there's a fair amount of steps. Make sure you show them in case you screw up somewhere. Okay? Because I'm still going to give you part marks for method if you happen to punch something into your calculator wrong. Right? So if you're showing all of this stuff, okay, and it's all correct, but you're for some reason not getting the right answers, I'll work back in your solution and know where you've gone wrong, and you're still going to get some part marks. Okay? Always show your work. If you don't, okay, and then you do something wrong, you make a silly typing error on your calculator, it costs you big. Right? So show your work. Right? I had a kid who just refused to do that one time, and there was nothing I could do to convince him otherwise. On his final exam, he forgot to turn his calculator back to degree mode after it was reset. He showed no work and got basically everything wrong. And because he showed no work, I could give him nothing. Okay? Show your work. Okay? Method is important. Okay? Kid knew how to do all of it, but I could tell from his answers, I knew exactly what he'd done wrong. And I can't give him anything if he doesn't write it down. Okay? And that sucked. It sucked for him, and it sucked for me too, because I knew he knew more than that. Okay? But I couldn't give him anything. So, show your work. Life lesson, show your work. Okay, I want you guys to try. Try E now, okay? Tricky, bit of a tricky diagram, okay? Make sure you draw the scale.
What's the difference between degree and radian?
Just the way that it calculates the angles. Yeah, it does it differently in degree and radian.
5.0?
Yes.
Is that 5.0 or
5.0 and 7.0. Okay, give you a few minutes to get ahead of me again there.
Damn it.
Okay, let's have a look at what the diagram, at least for E, is going to look like. All right, our first vector is 5 meters long, 26 degrees south of east. All right, so I'm going to start here in the middle. I'm going to draw my reference line east. I'm going to go 26 degrees south of that. Okay, so here's X, here's 26 degrees, here's Y, and this is 5.0 meters. All right, my next line, okay, is 7 meters at 58 degrees west of north. Okay, so I've got to draw a reference line that's north. Okay, I've got to go 58 degrees west of that. So almost back along the same line. Okay, and 7 meters in length. So maybe something like this. Now this is probably the trickiest one you would ever get in terms of drawing the diagram. Because it's pretty easy to draw this too long, right? This doesn't go past where we start, at least I don't think so. Okay, but I'll confirm with my math here in just a minute. Okay, maybe it does. Okay, but I'm going to check with my math here in just a minute because that can happen. Okay, it can happen to the best of us when we're drawing a diagram or like a vector diagram. So I'm going to say for right now that my result looks like this. Okay, but I could be wrong. And looking at the answer, I think I am. But I'm going to find out because this happens, and this is what we do when it does happen. Okay, so the first thing I'm going to do is find all the x's and all the y's. Okay, so I'm going to find black x first. All right, so black x is the adjacent side, so that'll be the cos of 26 degrees times 5 meters. All right, so that's 4.494 meters east. Okay, and then black y is going to be the sine of 26 degrees times 5 meters. All right, so that's going to be 2.192. meters, and that is south. Okay, now I'm going to do the same thing for my blue triangle. And right now is when I'm going to find out whether I drew this right or wrong. I drew it wrong, but I'm going to go with it anyway. Okay, so finding blue x. Blue x is the opposite side to my 58 degree angle. All right, so that's going to be sine of 58 times 7 meters. Okay, so it says that line should be 5.93 meters long. And I didn't draw it that long, did I? Okay, according to my diagram, black x is bigger than blue x, but according to my calculator, blue x is bigger than black x. So I'm going to write that number down, but I'm going to remember it this time, 5.936 meters west. And I'm just going to go, all right, I didn't draw this right, so I'm going to get rid of my green triangle because I know it's wrong. Okay, I'm going to get rid of that line there because I know it's wrong as well, and I'm going to adjust my diagram. Okay, so now I draw it like that. Okay, I draw this, and now my diagram is more reflective of my math. And we have to do that sometimes. Okay. There's no shame in getting the math done and going, oops, I drew the diagram wrong. Oh well, okay. I just go back and I change the diagram, just like I did here. Everybody all right with that? Okay. So rest of the way through here, okay, finding blue y is the cos of 58 because it's the adjacent side times 7. All right, so that's going to be 3.71. meters, and that is north. Okay, I'll give you a few more minutes to get further ahead of me again, okay, and then I'll walk through the last few steps here. All right, so last few steps here. Okay, we need to calculate what green y and green x are. Okay, so for green x, I'm going to take the amount west, which is 5.936, and subtract the amount east, which was 4.494. Okay, and that will give me how much west I end up of where I started, which is not very much. Okay, so 5.936 minus 4.4 2.3, I think it was. Okay. Whoops. Okay, so we're, oh man. I just totally messed that all up. I can just start over again. Okay, so we'll have in brackets the sine of 58 times 7 minus okay, so my resultant for the x is 1.442 meters. And that's west. Okay, but I need people paying attention. Okay, then I'm going to find the resultant y. Okay, one is south, the black one is south, and the blue one is north. Since I end up north, I'm going to go north minus south, so 3.71 minus 2.192. Okay, since I've lost all the decimals on there, I'll have to do it the long way here, which will be cos of 58 times 7 minus the sine of 26 times 5. All right, so I'm getting there 1.518 as my resultant y. And that's north. All right, so now that I've got the sides of my green triangle, I can find the displacement using Pythagorean theorem, and then I'll find the angle using trig. Okay, so it'll be 1.442 squared plus 1.518 squared. Okay, get our magnitude. All right, so my resultant's 1.93, 1.94 meters. So, and then to find the angle, okay, the way I drew the triangle, y is my opposite side, x is my adjacent side. Okay, so I'll have tan to the minus 1 of 1.518 divided by 1.442. Okay, and that will get me my angle. Okay, so I've got 46.4 degrees. And for me, that was north of west, the way I drew it. And my answer can only have two significant figures, because that's all I was given in the question. Right? Somehow I ended up with a different answer on there, but okay. Well, for the angle I did. Somehow I ended up with a different answer for the side, for the length. I must have typed something in wrong. Okay, but okay, does everyone kind of follow me on that one? I'm not sure where I went wrong with the sides, but okay. All right. I want you guys to try. Not that one either. Okay, I want you guys to try number 9 because this is going to lead us into a whole new type of vector question. Okay, we call them boat questions because they're usually a boat, but they could easily be an airplane as well. Okay, but we're going to be looking at these here in a minute, right? But I want you to start out with that one. It's relatively straightforward. Okay, actually, you know what? I'm going to make one up first, and we'll do the one I make up first. Yes. Okay, so let's try this. Let's say I've got this river here. Okay, I know that this river is 150 meters what? Okay, and here's the other information I have. A boat is headed straight across a river that flows east at 1.4 meters per second. The rower who's rowing the boat can row at 0.75 meters per second. Okay? How long will it take to cross? Okay. Part B, how far downstream will they be? When they get across. Okay, write that one down because it's going to be a good example of a boat question for you. We haven't done a boat question yet, so I want you to write this down and I'm going to walk you through it. The math is really easy. Okay, like the math of this question is really, really easy, but getting to it is the part that usually trips people up. So these two vectors need to be drawn so that we can see what's going to happen in this situation. Okay? One of the vectors is the current. Okay? The river current is 1.4 meters per second east. Right? So I've drawn that. The other vector is the rower. Okay? And the rower can row at 0.75 meters per second. Okay? Like so. So I've drawn them tail to head. First I row, and then the current pushes me, or they both happen actually at the same time, and I result in this. Okay? In this case, the resultant is my average velocity. The question never asked me to calculate that, so I'm not going to, but that's what it represents. Okay? All the other questions we've done, we've been adding two displacement vectors. Now we're adding two velocity vectors. It doesn't change what we do. It just means that in the end, we'll get meters per second instead of meters. All right? So, this is the initial setup. Okay? I need to know how long it will take to go across. Now, the trick with this is that I know how far it is across the river, and I have two velocities. Okay? How do I figure out how long it'll take me to cross?
Wouldn't he start at the one end of the river, not in the middle?
He does. I just didn't draw it that way.
Oh.
Because I didn't want to draw a triangle that was like this big by that big. Right? This is a scaled down version. Yeah.
150 meters divided by 0.75 meters per second.
Exactly. Okay? I'm going to take the distance and I'm going to divide it by the velocity, this one, okay, in order to figure out how long it will take to go across. The reason I use this one is because they both point north, the same direction. I can't use this one to tell me anything about this direction because this doesn't go north. Okay? And a similar thing is, a lot of times people will calculate the resultant and then use it with the 150. Do they point the same direction? No. It's a lot longer to go across the river along V. Okay? But in actual fact, it would take the same amount of time, but the distance would be great. Okay? I know the distance across. I know the speed across. So I can use them together to calculate the time by manipulating v equals d over t, okay, finding t. So for this one, that's going to be 150 meters divided by 0.75. All right, so it's going to take 200 seconds to get across. All right, here's the other thing to think about. All right, so that's answering part A. Okay, how long will it take to get across? 200 seconds. Now, the whole time I'm in the river rowing across, I'm also going. Right, I'm also moving at 1.4 meters per second east. I'm going downstream. Okay, the entire 200 seconds I'm going downstream. Can I calculate now with this number and this number how far downstream I go? Yeah. Okay. Now it's going to be d equals v times t. Right? The time is the same for all three sides of that triangle because they're all talking about the same trip, which takes 200 seconds. And so I take my 1.4 and multiply by 200. Okay, so that should give me 280 meters.
Yeah.
Yeah. Oh, something's escalating across the hall. Right, 280 meters, and that would be east. Okay. Everyone all right with that? That's a typical boat question. Okay. Now, a boat question can also work like this. Okay. They can work in a different way. Does anyone need this one anymore? Place question.
Wouldn't it be north and east? Because they're traveling. Yeah.
Nope. It only asked how far downstream I went. Downstream is east.
Okay.
Right? If it asked what's the actual displacement from one side to the other, then you're right. I would need to find out how long this red line is. I don't know that yet, and I don't need to know that for this question. Okay, so the other way that this could work would be something like this. Okay? Okay, so a boat question could work like this. It could be a plane, and it could be a plane that is flying in a crosswind. Okay? So write this one down, because this is another example of a boat type question. Okay, but the wording on this one is different. The one we just did, it said the person was heading straight across. They don't end up going straight across. In this one, they want to know which way I have to head in order to go straight across. Okay? So it works a little bit, the diagram works a little bit differently. In this case, I end up going straight across instead of I'm heading straight across. In what direction must you head? In what direction must you go? You're heading. That's where that comes from. Okay? Heading.
Did you mean to write two things in different units? Kilometers?
Oh, no, I didn't mean to write them in different units. Good eye. Yeah, flying a plane in 50 meter per second winds. Not a good idea. Big crosswind. All right, so the vectors we have for this question are the maximum speed of the plane and the wind. Okay, they're going to produce a resultant that is due north. Okay? The question told me that. Okay? In what direction does it have to go in order to end up flying due north? So this is my resultant. Okay? Due north. The wind is westerly, which actually means it's blowing from the west. It's actually blowing east. Okay? So I know I have an easterly wind of 50 kilometers per hour. Or sorry, a westerly wind blowing east, okay, of 50 kilometers per hour. So that means that the plane needs to fly slightly into the wind in order to end up going this way. We know that the maximum speed of the plane is 200 kilometers per hour. They want to know what direction are we going in order to make this happen. Okay? So in the end, I only have to do one calculation here, but there's a fair amount of thought that goes into getting there. Okay? That's the difficult part of this question, is the intuitive leap that has to happen before I get to the relatively easy mathematical part of the question. Right? So I've got to find theta, and I've got the opposite side, and I've got the hypotenuse. All right. So if I want to find theta, okay, the sine of theta relates to me the opposite side and the hypotenuse. So if I want to find theta, I'm going to go sine inverse, okay, or sine to the minus 1, of the opposite side, which is 50, divided by the hypotenuse, which is 200. Okay, so that plane has to fly 14 degrees. Which direction?
West. North.
West of north, right? This is north. I got to go west. If the wind's blowing east, I need to go slightly west so the wind blows me back to straight. Okay, so that'll be west of north. And that was 14 degrees. Right? So that's another way that a boat question could work. Okay, anybody need that one anymore? Go down? Okay. Then, try this one, because it's just like the one we just did. So we'll see if you can apply what we just did. Okay, so we've got our river here. Okay. A boat can travel on still water at a speed of 3 meters per second. That means that's the maximum speed of the boat. Okay, it's as fast as the boat can go. And it wants to travel north perpendicular to the current. Okay, if it wants to do that, that means it's going to end up going north. Okay, because that's what it wants to do. So that means our resultant then is straight across the river. That means then that the combination of the current and the speed of the boat have to add up to this. All right, so the speed of the boat then has to be, or is 3 meters per second, so it's going to look like this. And then the current is going to push it back to straight at 1.2 meters per second. So all the question wants to know is, what's your heading? Okay, what angle do you need to row into the current at in order to end up going straight across? Because if I want to go straight across the river, if there's a spot on the other side I want to get to, I don't aim for that spot. I row upstream a little bit so the current can take me back over to that spot. Okay, this is like a pilot has to do this flying a plane. If you want to end up in LA, okay, from Calgary, and there's a wind, usually there is, blowing from the west, you don't head for LA. You head for the open water and you let the wind blow you back. Okay, to straight on course again. That's how you have to do it. So they have to know wind speed, direction, all of that. They have to change their heading as they go.
What does it mean by the still water then? Because it says you can only travel 3 meters per second.
Right, that's the maximum speed of the boat. So even into the current, that's how fast they can row. My result is not that I can row that fast. Right? I end up, like the size of this green line is not 3 meters per second. It's going to be slower than that,
Yeah.
right? That's how fast I could go if there was no current. But because there's current, I won't end up doing that. Okay, does that make sense? I'm saying I could, but the current means I can't. Okay, so while I could row that fast, I don't end up rowing that fast. Okay, so I see what you're saying. We're saying the same thing here. If I'm in the water, I'm not going to row that fast. You're absolutely right. You're going to row
But
this
that's-
fast.
That's what I think, because
Yeah.
since it's going straight, that's like this still, it's not moving.
Well, no, it's saying if there was no current, you can row this fast. Okay? What we're saying in the diagram is you're going to row as fast as you can. But you will only end up going this fast. But this rowing as fast as you can contributes to this. Okay? And that's why this ends up being shorter than as fast as you can row. Right? If I rowed straight across, I would go across at 3 meters per second because the current wouldn't affect my speed. Okay? But as soon as I row into it, then it does. It slows me down. If I rowed this way, downstream, I'd go faster. Okay? All right. So now we need to find theta. Okay? Theta is the heading of the boat. So I've got the opposite side and the hypotenuse, so it's the same calculation we just did. Okay? The sine of theta equals opposite over hypotenuse. So theta equals sine to the minus 1 of 1.2, the opposite side, divided by 3, the hypotenuse, and that'll give us 24 degrees west. Okay, so those are very, very typical vector addition questions. They don't involve you having to find x and y and do all that math, but they make you think. Okay, so in that way, they can be just as hard. They're just not as time consuming if you know how to do them. All right. Okay, try number 12. Okay, another boat question, but not quite like the one we just did. More like the first one that we did. Okay, so write this one down, or you have it in your worksheet booklet, so you don't need to write it down. Okay, I want you guys to try that one. There has not been a unit exam where I did not have a question like this. Yeah, that's what I meant for you to do when I said that.
Oh.
Yeah. I wasn't trying to be coy. So, for this question, listening please. All right, so the question gives us the speed of the boat. Okay, it said it can travel 4 meters per second on still water and is heading directly north across a river. All right, so I'm going to draw that all the way. Okay, this is 4 meters per second. It also says that the river's flowing at 2.1 meters per second east. And that the river is 125 meters wide. Like so. Okay? So the question wants a couple of things. First off, it wants the resultant velocity of the boat with respect to the shore. Actually, that's not the angle I put on here. Okay? The angle I put on is not the one that is with respect to the shore. All right, so this is my resultant velocity. I need to find that. Magnitude and direction, except the question specifically says they don't want that angle, they want this one. All right, that's fine. I just find this one and then go 90 minus that number, because they'll add it to 90. Okay, so first thing I'm going to do is find the magnitude of that velocity. That's just Pythagorean theorem. All right, so all I have to do is go 4 squared plus 2.1 squared. Okay, so we're looking at 4.517 or 4.518, okay, which will round to 4.5 meters per second. Okay, so this is 4.5 meters per second. I want to find the angle, right? So for me, I'm just going to kind of flip the triangle and make this side 2.1, the other side 4.0, right? And just do a second tan of that. So second tan of 2.1 divided by 4. So I'm getting 28, oh, sorry, I did that the wrong way. I did that the way I have it drawn here. Okay, so I've drawn it, I drew it this way, that's the way I did the calculation. This angle is 28 degrees, but I want this one, so I go 90 minus that, this is 62 degrees. north of east. So now I've done part A. I found the resultant velocity, magnitude and direction. Then I need to find out how long it'll take the boat to get across. Hardin, question.
So how do you know which angle to find?
Well, this one said with respect to the shore. That means measured from the shore. Okay, this is the only angle that would touch the shore, right? Okay, so how long does it take the boat to reach the opposite shore? Well, it's 125 meters across. How fast am I going across? 4 meters per second. Not this speed. This is the most common mistake, is people use this speed when it doesn't point across. It points across and down, and that's different. Okay, I can only use numbers that are parallel to each other when I'm doing a V equals D over T calculation.
Why is this still water going straight this time and not? Like,
It's just, whenever it says this is how fast it can go in still water, it's saying that's how fast you can make it go.
But on the other question, you had the still water going backwards.
I know. Again, the still water is just saying this is as fast as it can go. Okay? It's not saying anything about the direction. It's saying if there was no current at all, it could go this fast, draw the line this long. Okay? It's not saying it's going to end up going that fast. In this case, it ends up going faster than that. That's just as fast as I can row it. Okay?
So why in the last question did you go backwards?
Because it said I was going backwards.
But that was the still water.
Don't worry about the still water part. It's telling you how fast you can row Easton. Okay? When it says the boat can go this fast, it's saying that's how fast the boat goes without anything else. This is how fast the boat goes without anything else. The boat ends up going this fast, the red line. Okay? I'm just saying that's how fast the boat can go in absence of everything else.
So
Okay?
wouldn't it be straight on the last question too?
No, it wouldn't. It's saying here's how fast it can go in this direction. Okay? It told you it was going this way. This one it told you it was going straight across. You're really overthinking it, dude. Okay?
Still water.
Just ignore the still water parts, how fast the boat can go. Okay? All right. So I've got my 4.0 meters per second. I've got my width of the river here. So I want to find the time. Okay? T equals D over V, right? And that's going to mean 125 over 4 to get me the time to get across. And that is 31 seconds, right? So it's going to take me 31 seconds to get across the river. Everybody all right with that? Okay. The whole 31 seconds, I'm also moving downstream at 2.1 meters per second. So for part C, the distance downstream or displacement downstream will be V times T, 2.1 times 31, okay, which is going to give me 66 meters downstream. Okay. That's how a boat question works. Like I said, there's not been a unit exam where I did not have a boat question on the unit exam. Sometimes it's a boat, sometimes it's a plane, but it's always a boat question, okay, of this nature.
Make sure you tell me.